Mr. Adewale. So we are considering sectors and arcs now. Just want to consider some few questions on sectors and arc. And that's, we are talking of a circle now. Sectors and arcs of a circle. So let's quickly consider the two questions we have here. Number one. All right. Before I go into that, let me quickly tell you this now. The area of a sector. Yeah. Area of a sector. That's a theta over 360 times that's pi r squared. So you should note that area of a sector is theta over 360 times pi r squared. The length of an arc, that's theta over 360 divided by 2 pi r. So you should just note that. So let's go into our questions here. A sector of a circle. Now, when you have a sector of a circle, this is a sector of a circle. This is okay. So start at angle 60, and then has a side radius 6 cm. This radius 6 cm. You have to calculate the perimeter in terms of pi. The perimeter So perimeter of a sector of a circle, that will be length of arc plus 2 pi r. Please note that the perimeter of a sector of a circle will be the length of arc, and that is theta over 360 2 pi r, then plus the two radius 2r. That's the perimeter. So that will be 60 over 360 multiplied by 2 multiplied by 22 over 7 multiplied by the radius, that's 6, plus 2 multiplied by 6. So here 1, 60, here 1, here 6. So invariably, so let's go back to the question. Said a sector of a circle with radius 6 centimeters sustained an angle 60 degrees at the center. Calculate the perimeter in terms of pi. So we still leave the pi. Since we have to calculate it. You don't have to change the pi in terms of pi. So you leave the pi. You don't change it to 20 over 7. Since we are doing that in terms of pi. So from there, let's continue. Divide by 6 plus 12. So 6 cancel 6. So we have 2 pi plus 12. And that is 2 brackets pi plus 6. So centimeters. We're calculating perimeter. So that's the answer in terms of pi. So the second question we have there is a 120-degree sector. A 120-degree sector of a circle of radius 21 centimeter is bent. A sector is bent to form a cone. What is the base of the cone? What is the base of the cone? So how do we do this now? Now, a sector. This is a sector. Then it has an angle 120. 120. Now, and the radius is 21. Something like that. Is forming a cone. This is a cone. So I want to get the base radius. The base radius of the cone. How do we do that now? Alright. So what we do now is we want to get the base radius here. Now, that means the length of the arc of the sector of the circle will be equal to the circumference of the base of the cone. Meaning, what do? You equate the length of the arc of the sector to the base, to the circumference of the base of the cone. So that's what you simply do. Now, and that means theta over 360 multiplied by 2 pi r. Now let's call it capital R now. Will be equal to the circumference of the base of the cone. The circumference of this circumference is 2 pi r. So what we want to get is the small r. That's the base radius. So this is 120 over 360 multiplied by 2 times 22 over 7 multiplied by 21 will be 2 multiplied by 22 over 7 times r. Here 1, we have 3, 3 here 1, 3 here 7, 7 cancel 7, we have 44 equals 44 over 7r. So r would be, so let's say 44r would be 44 multiplied by 7. So r will simply be 44 times 7 over 44. And so the base radius asked to calculate is 7 centimeter. 7 centimeter. Now when you are anytime you are dealing with calculations or work on when a sector turns to a cone, just know you want to calculate it. A simple formula you can just simply use is r equals r theta over 360. Anytime you are dealing with work that has to do with conversion of cone sector to cone, so where r is the radius of the cone, r is the radius of the cone of the cone, the base cone. Now, and then capital R is the radius of the sector. So, and theta is the angle of the sector. So R will simply be the capital R, which is the radius, multiplied by theta is 120 over 360. Here 1, here 3, 3 here 1, here 7. So radius will be 7 centimeters. This is just a formula way. So when the sector converts to a cone, so that is it. I hope that is clear. God bless you. Thank you.
Yes.
So these two questions are to be attempted. Now I've given the formula for the length of an arc. That's theta over 360 multiplied by 2 pi r. So you can quickly use it, and then you get your angle. So an arc of a circle of radius 7.5 centimeter is, that's the length now, 7.5 centimeter long. So you have to find the angle. And then the second one, the same thing, length of an arc again. So the formula is there. Then you calculate the angle. Then you leave your answer at the comment section. Thank you. God bless you.